Hi, this is Choose Your Own Lab, Conservation of Momentum for Lab 5, Physics 2211. So for an introduction, the purpose of this lab is to model a collision with pool balls. Some models and fundamental principles used were tracker, glow script. We also utilized iPhone footage. Some important equations, which I'll show more later, is conservation of momentum, velocity, and position update, net force, and a preview of the main result is the model on tracker, and it's modeled like the collision to demonstrate the pool balls relatively well with few minor errors. There is a relative conservation of momentum. So some of the main physics ideas here are shown. Conservation of momentum is important because it's important when objects collide, and it just means the momentum at the beginning should be the same as momentum at the end. Velocity update formula and the position update formula were utilized in the code to make the balls move correctly. The net force was used to express the forces output on the balls, and kinetic energy is used to determine the type of collision. The system is both pool balls, and we put nothing in the surroundings in our experiment. The initial conditions, so the mass and radius of the pool balls, the mass is 0.16 kilograms and the radius is 0.0286 meters. The positions are shown here as well, and so are the velocities. So those were all of our initial conditions. The experiment details, so we took footage of two pool balls colliding on the pool table to show an above view point. We utilized tracker to track the motion of the footage in each pool ball, and then utilize the videos on tracker to model a code on GlowScript based on the motion of the pool balls, compared to the tracker and GlowScript data in order to observe how collisions work and use all these things to analyze the motion within this lab. This shows the tracker footage and data. I plotted point by point both the Q and 8 ball to determine the velocity and the change in velocity, including the speed and direction of both balls. So here's a picture of us taking our video, and then pictures of the tracker analyzing. So then these are the coding details. You can see the changes made to create the graph and balls at the top left. At the top right, there's the initialization for the mass and position and velocity. At the bottom of the right, I used force and velocity and position update to initialize the data for before the collision. And then in the bottom left is the data after the objects collide to show different velocity. I utilized some online videos in order to get the coding working and to get the balls to actually collide and change velocity. So that was super helpful in my process. Here is the output of the code. It shows both the image of the collision and the position and time graphs of both 8 ball and Q ball. So you can see both balls in that image as well as both of the graphs. So some similarities and differences. Some similarities, so both the tracker data and GlowScript found the collision to cause a more dramatic direction change in the Y direction than the X direction. They demonstrated the same data with the same velocities shown in the tracker footage. Both images showed an overhead view of the pool balls colliding, and they used the same time interval and axes in order to create more similar graphs. Some differences, so the real footage data had another direction change due to a collision with the wall, but this was ignored in the coding model just to simplify it a little bit more and only have one collision involved. So the code demonstrates the ball's direction as if it had not hit the wall. The GlowScript model demonstrated a more perfect collision with straight lines. The GlowScript data was shown in both of the pool balls, change of velocity in the X and Y directions, but the tracker data split them up by a pool ball and the XY direction. And the real world model has friction, but the GlowScript model ignores friction. Was momentum conserved perfectly? So we solved for initial momentum and then final momentum. So as you can see, the initial momentum and final momentum are not the same. So momentum was not technically conserved, but this is just due to the real world factors that were not taken into account. So a large one is like friction and the energies that release as sound and thermal energy when a collision occurs, like you hear the pool balls collide, which is taking out energy. So if these were included within this experiment, we demonstrated how many different things affect conservation of momentum. Possible sources of error, so not perfectly placing the motion of the balls in the tracker data. This could lead to inaccurate center of mass, and this could lead to less accurate data and speed shown throughout the experiment. Lack of accounting for friction, as I said in the previous slide, as well as sound. The real-world model has some friction that could affect the motion of the objects, but the GlowScript model doesn't account for this because it's most likely minimal friction, but it would still be present. We had to estimate the actual speed off of the graph, so we used the data from tracker for speed to input the GlowScript model, so it could have been slightly off due to lack of accuracy in the plotting on the graph, so causing slight changes in the slope. And we used the estimated mass and radius for the pool balls from the internet, so the mass could be slightly different. You don't actually know if they're the exact same. And the video is very short, so the time intervals were slightly inconsistent due to need of slowing down motion in order to properly observe it. Some additional questions. So what does it mean to be perfectly elastic? Was this collision perfectly elastic? So to be perfectly elastic, no kinetic energy would be lost when the pool balls collided. The initial kinetic energy would be that as shown, and the final would be that. The change in kinetic energy would be negative 0.1901 joules, so there was some loss in the collision, and it's inelastic, most likely due to the real-world restrictions like friction. Another initial question, so if the mass was larger than another, would it affect the elasticity? What would happen? So if one mass was larger than the other, it would make the collision have a greater momentum due to P equals mv. The larger mass would experience a much smaller change in velocity when the objects collide, and it would maintain the majority of its momentum prior to the collision. It would not affect the elasticity of the collision because that's based on the materials of the object colliding. Thank you!